Hi everyone, Mrs. Basega here, and today we're working on two key applications of magnetism. That is the motor and generator. So in your notes, make two columns, one for motor, one for generator, and let's get started. We'll start off with the motor. A motor is a device that turns electricity into kinetic energy. This uses the magnetic force because in this case, it produces a torque on the coil. The magnetic field points from north to south, creating a magnetic field that goes to the right, while the current goes into and out of the page, creating magnetic forces that turn the coil. Thus, the two objects in this interaction are the coil, because that has the kinetic energy, and the magnet. In this case, it's turning electrical energy from the battery into kinetic energy of the coil. Please notice I left off the P for the potential in electric energy because this is not potential energy. These electrons are actually moving. And since they're actually moving, it's not potential, it's just regular electrical energy. So electricity turns into kinetic energy in a motor. Some common examples of motors include fans. Think about it. It runs on electricity and produces kinetic energy. Or a dishwasher, washing machine, dryer. They run on electricity and produce movement. Your speakers or headphones do the same thing. There's magnets on the inside of your earbuds, and that creates kinetic energy of moving the membrane back and forth. And you and I hear those vibrations as sound. So a speaker or a headphone turns electricity into kinetic energy into sound. When we originally did electric force, we did the example of a railgun, which took electricity and turned it into kinetic energy. An electric car, though more rare, turns electric energy stored in a battery into kinetic energy of the entire vehicle. While we normally will picture a motor like this in its simplest form, electric motors often look significantly more complicated. They have their conventional current going from positive to negative, represented by the green arrow. But this time it has a much more complex coil system. The more coils, the more magnetic force, so the more kinetic energy. Now, a generator is just the opposite of a motor. And you'll notice that this picture looks very similar. It has a stationary magnetic field with a turning coil in the middle. But notice that instead of using voltage as an input, it's having voltage as an output. Because something is rotating this coil, it's creating an alternating current inside this coil. This is an alternating current because notice that the voltage is switching back and forth from positive to negative. So this energy transformation turns kinetic energy into electrical energy. No P for potential here. This is actual electricity with actual electrons flowing. Again, it's a coil interacting with a magnet. Now, it turns out 96% of all the electricity generated by humans on Earth comes from generators. This type of generator would be called a hydroelectric power plant because this is taking moving water. Its kinetic energy is spinning the generator and it's turning the water's energy into electrical energy. So it's kinetic energy of the water turns into kinetic energy in the generator, which eventually turns into electrical energy in some homes. What about if instead of relying on falling water, you relied on some object forcibly moving the generator? Some examples in this case might be your home generator. It relies on an engine that moves its turbines back and forth to create electricity in the generator. It has kinetic energy from the movement of the engine that turns into electricity for your home. This could be a hand crank generator where you spin the crank and it turns on a light bulb. This could even be a wind turbine. This could be something where the wind turns a turbine that turns a generator that turns on a light. But in fact, the most common form of generator isn't wind or hydroelectric or human powered or running on an engine, these would be things like coal, oil, natural gas, biofuel, and nuclear. All of these at the bottom here actually use heat and steam to turn the generator to create electricity. Imagine for your coal or biofuel power plant, you put wood in on the bottom, we light the wood on fire, it heats the water, and the kinetic energy of the arising steam turns the turbines to make the electricity. Nuclear power does the same thing, except instead of burning things that let off extra carbon dioxide into the atmosphere, it does a nuclear reaction, which heats water, which turns the generator, which creates electricity without carbon dioxide emissions. So, to sum it up, to check if something is a motor, check to see if it runs on electricity. If it runs on electricity and creates motion, that's a motor, like an electrical fan. It runs on electricity and it creates kinetic energy. Whereas a generator could look very similar, but notice that this is taking kinetic energy from the wind and turning it into electricity. All right, folks, that is all, and I'll see you next time.